I'm Paul Vennemark, and this is Marcelina. We're doing this together. Marcelina is manager for the applications group, and I'm running around somewhere. So this is, it's called high performance computing, but it's more like an introduction to Slurm, but also how to get it on our systems. So our breakdown of this presentation is like, and it's going to be interactive and non-interactive. So there will be a little bit hands-on experience that Marcelina will do. But first, the introduction, what is the Research Computing Center and what is high-performance computing? After that, we'll go into kind of the details, how to submit a job, what things are exactly. And if we have time or if there's questions, we have some more advanced topics. So what is the Research Computing Center? So we started many years ago as the shared HPC facility in academic department, but in 2013 we moved to central IT just because our customer base was growing to different colleges. We started as the College of Arts and Science and later became medicine, engineering, whatever you have. And so now we're kind of a university-wide unit. And we have a team that, I have to look at because otherwise I just make up random stuff, that hosts administrators and application specialists. And we are the main HPC facility on campus. In the past I would call it supercomputing. Now it's just a cluster of compute servers. Or as you can say, it's an on-demand cloud. Or the fancy word is actually serverless computing. So what is high-performance computing? Well, if you look online, you will find 50,000 different definitions. But it basically, you can sign in with Alex if you. It's like research computing. It means like if you have a problem, if you have an application, if you have a model that you can no longer run on your regular desktop and needs larger computational power. That can mean more memory, and that can mean more CPUs. If your Earth or atmospheric model needs 1,000 CPUs, you'll probably not be able to run it on your desktop. If you need specialized hardware, well, we give a whole list of nice acronyms, so no one probably knows what they mean, but it's like specialized hardware. Or if you just want to run a job and you don't want to wait for it, it may take 2 weeks, it may take a month. You don't want to run it on your desktop because Windows likes to reboot every week. So you can offload it to our systems, it will just run. You just walk away, you come back a week later and it's finished or still running. So some definitions. So what is an HPC job? What's the anatomy of an HPC job? So in general, we kind of divide it as you have your program, your application, your model, your Fortran program, your Python program, and then you have some type of data. It doesn't really matter what, it doesn't really matter how big it is. For some people, big data is a file that's like 15 gigabytes. For some, it's a file that's like 100 terabytes. But in general, an HPC job is confined as you have your application and you have your input data. And then you submit that to a cluster. One of the old-fashioned ways of looking at HPC is that it's non-interactive. You'll probably hear a lot the term batch. Batch computing is like that. You have your application, your data, and you submit it to a job. It doesn't need your input. It just runs, and at one point, you'll get an output. And you'll get a notification by email. You see that it finishes. Another program that depends on it, output starts again. But this is in general a typical HPC word job. Now we'll later go into interactive because sometimes you want to run things interactively like a MATLAB or a Jupyter Notebook. But in most of our jobs are non-interactive batch jobs. And let's just admit. I'm always afraid if I admit someone. So how does it look? How does it? Well, you've probably all seen racks of computers in advertisements for Google or whatever company, but how does it really look like? So in general, you can see our cluster is just one big box with all similar kind of little computers. Our system here in Innovation Park is roughly 800 nodes. It changes every year. Most of these servers are pretty similar with 2 or 4 processors. It's just that core density, the amount of cores per CPU grows. So some of our newer machines have 64 cores per CPU. You get 128 core machines. Most of these desktops will probably have 4 or 8 cores, maybe if you're lucky 16, but probably 8. Then you also have threading, which I'm not going to. And these are going to be Intel or AMD. We don't have anyone who came to us and said, can you buy ARM CPUs yet? But who knows? Now these machines all have a lot of memory, so some of these nodes have 512, or maybe our newer machines might actually have a terabyte of memory. And these are all connected with a very fast network. The network is actually 200 gigabits, but most of these compute nodes have 56 or 100 gigabit per node. So these machines here all have a 1 gigabit network. So these machines most of our machines have 100 times faster network than these machines. As a comparison, kind of how integrated it is. So it's one big cluster, that's why we usually call it a shared resource. It's just not one person that can claim the whole machine, it's shared with different people. Your desktop is used by one person, you, although you can let someone else log out, but there's only one person using it at the same time. If you look on our systems, there's usually like 100 people running at the same time. So that's why it's a shared resource. That means that there may be contention between resources. You don't want to run everyone to run on that one core. You have 13,000 cores, you want to evenly spread it out over our resources, over our users. So that's why you need something like a job scheduler. Job scheduler makes sure that your job will run as fast as possible on your own little piece of that cluster. And there's many implementations of job schedulers, but what we use is Slurm, which is simple Linux resource manager. It's a very weird acronym the first time you hear Slurm. It's like, what? It makes sure that your job continue run on your little part of the cluster and will not interfere with anyone else, or that anyone else can interfere with your job. You don't want to start your linguistic model and then after 3 weeks find out that one of your colleagues kind of by accident killed your node and the job's killed. So that's why we need the job scheduler. Now, there's multiple ways of submitting jobs, and we do it through accounts. So an account is like a checkout lane in the supermarket. You can see if you have multiple lanes, there's the regular lanes, like where you go to, but sometimes you have this 10 items or less, which is like a fast lane. And if you only have like if you only have like 4 bags of chips or whatever, you just go to the fast lane and you're done in no time. That's the same thing what we have in Slurm. We have some of our regular that everyone uses. There's some fast. One of the analogies I always make is like a conveyor belt in like Amazon. There's your regular shipping, the free shipping, but some people have Prime, and Prime get priority and their package will ship. I don't think anyone else, doesn't have Prime anymore. So that's why I always use this analogy. This is like your conveyor belt. There's the full line with all these packages. You buy your whatever you have, and it's free shipping, and hopefully it will come in a week. But I think I want to have it fast. I do the 1-day delivery, and that's the high priority. Now, is high priority free? Well, here comes the tricky part. We are what's called cost recovery, so you can get free resources or you can pay for high priority. And that's with Amazon and that's with us too. But I will not go too much into the details. So, how do you access the HPC? It sounds like a very nice machine. Do you have to drive out to Innovation Park with a floppy disk? No one knows a floppy. With a memory stick and insert it in the machine? No, you don't. You have to access it remotely. There's several ways, and now we're getting into the mumbo jumbo. There's two main ways to get access to a machine. There's a graphical interface, which is very easy to use. The tool we used for it is called Open on Demand. And there's the command line interface. We are, after all, a Linux shop. All our machines run Linux. So the easiest way to get access is use SSH. SSH is secure shell. It connects it makes a connection from your desktop to our login nodes, to our cluster. Now there's many different variations of SSH implementation. On Windows you can use PowerShell and type SSH. There's something called Cygwin, which I wouldn't advise not to use. There's MobaXterm, which is like another graphical SSH implementation, etc., etc. If you're on Linux, you have your Linux terminal. If you're on Mac, you just open your Mac terminal, you type SSH. All these ways to connect directly to our machines. So on your right screen, we have two examples. Open on demand is basically you have a virtual desktop on our cluster. It can be very handy if you want to run something with a graphical output. But if you only want to submit a very simple batch job, you don't really need it, and it can be cumbersome. If you have SSH, it's very fast, but like I said, you only have text output. But if you just want to submit your little R job or your WRF model, then the command line is the easiest. It's also the easiest to check. It's very fast. You just open it up and it'll pop up for you. So I mentioned the graphical interface. What we use is open on demand. If you've used the FSU VLab, that's called Citrix, which is very expensive. Open on demand is free to use for everyone here. It doesn't depend on student tech fee. So we have several applications in it. One of which is your regular desktop, which I showed a picture. But we also have MATLAB. We have Stata, which is a statistical package. We have Visit, which is like a graphical visualization package. Yeah. And then we have things like Jupyter Notebooks, RStudio Server, and we have several specific visualization packages like PyMol and VMD for molecular dynamics. All these acronyms are very easy. Visualize Molecular Dynamics VMD. Yes, I see someone sees a light. I was like, oh yeah. So if you want to explore this, we have the website is called ood.rcc.fsu.edu. We will not go too much into Open on Demand in this workshop. There are other workshops where we'll go deeper into the Open on Demand because there's a lot of different things you can do with it. Not only applications, but also copy files between your machine and our cluster. Or have job templates or blah, 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 blah. There's a lot of more possibilities. So command line interface. Like I said, we are a Linux shop. We don't run Windows because most scientific applications are built on Linux. It also makes it much easier to run in a cluster formation. So last week we had an introduction to Linux, and I just heard that in 2 hours the presentation will be online. Or was it tomorrow?
2 days.
2 days.
Sometime this week, most likely.
Yeah, we have to pressure these people in the library. So, like I said, to connect to our Linux machines, you have to use SSH, which stands for Secure Shell. And if you're slightly older, you probably still remember the telnet command. This is the newer version of telnet. I don't know, I should date myself. So below it, this is an example how it looks like if you use a black background. It's just a bunch of text. So
yeah, so it all skipped over to me, but so far, do we have any questions in person about what we've covered so far in terms of our HPC definitions, as well as like in general how HPC works, and any of those terms? And I'll also pause to see if there are any questions on chat as well. Okay, so so there are a couple different ways to submit a job. So basically, you have an interactive job and a non-interactive job, and we'll go into those in depth a little bit later. But these are the basics on how to submit a job, regardless of interactivity. So, as Paul mentioned before, the necessities for running a job on the HPC is a program and optionally some input data. And then, of course, if we are going to ask the job scheduler to schedule our jobs, the Slurm needs to know how how many resources that you're requesting. And so that doesn't automatically pop up. We have to give it some parameters depending on how we're going to submit it. So we can either submit it as a submit script, which is a .sh file, as a command, which is an interactive job, which you can also do through either the command prompt or the terminal, or OOD parameters, which is our open on-demand graphical user interface, where you just manually import all of the parameters that you need. So how many nodes that you're requesting, how many cores you're requesting, if you need GPUs, how many hours you're going to be using it, that kind of stuff. So we'll go into first the anatomy of a submit script, because it kind of tells the format of how you want to submit all of these parameter requests. It starts off with a preamble that says, here are the particular resources that I need in terms of time, in terms of space, and essentially what it does is you have the preamble of the resources, and then at the bottom of your submit script you have the actual code that you wanted to run. So if you were to import or input all of this information directly into the command line, we're just putting it all into one script, so that way when you send it off to the job, it'll evaluate the resources that you need and then run your code. So the preamble of a submit script looks very similar to this, where it starts with the bin bash shebang line on the top, and then has a couple of these pound sbatch lines, and then at the bottom is where we're loading in software and modules that are necessary to run our code, and then srun trap is essentially running the trap code for the trapezoidal process. So just to explain what's happening, it's a uppercase J for the job name. So this is important when you're checking the status of your job to know what the job name is. The -A is for the Slurm account, and we'll talk about in specific the ones that are available through general access. And if you have a research lab that you're working with that's already using our systems, they'll have their own Slurm account name that you can use. The -n, lowercase n, is the number of cores that you need, and -t is the amount of time that you think that your job will require. This is a very hard set number, so once it hits 15 minutes, the code will stop. And the same thing about the nodes is that if it exceeds those the number of cores, so if it exceeds those number of cores, then it'll say and produce an out of memory error. And we'll go into a little bit of troubleshooting as we go. But the last thing that I wanted to mention is that there's a --mail type, which is part of those resource parameters. And basically, it allows you to have email notifications for every step of the process. So when you originally submit the job, it'll stay pending until those amount of resources that are available on this are available for you to use. So it'll say pending, and then the job status will shift as it starts, as it's going. If it fails because it encounters an error and then stops the entire job, or if it finishes successfully. So if you use the mail type equals all, then you're basically saying at every step of that process, let me get an email for when it shifts into a different state.
What are states? What are states?
I don't have that on here. But I did mention like pending is one of the states. Another state is in the process,
Yes.
so running.
So mail type can be that it starts if your job starts, when your job ends, or when you abort it. So when something error happens at abort. So there's like.
Yeah. So yeah, are there any questions about the preamble of the submit script, since this covers a lot of information? We also have documentation on our website discussing what we recommend, or what are all the different resources. These are only a very small subset of what we already have, but these are recommended if you're just starting to run jobs. These are what we recommend as part of the process. Yes?
So Slurm account, it's the same account we use to log in into on-demand, or is it
Different.
Can you repeat the question?
Yeah, so to repeat the question, are Slurm accounts the accounts that we use to log into RCC, or are they different? And they're essentially the lines that Paul was mentioning before of where you can submit the jobs. And so actually I think, so no, these are actually what we are referring to in terms of Slurm accounts. So these are all the ones that are available for free. If you're a faculty or student or staff on our systems, general access, it's Gen ActQ, the 2 backfills, Condor and Quick Test, and they have different limitations based on what you need for your job. Are there any questions online? Nope? Okay, yes.
So when we go through the interface, the graphical interface,
Mhm.
it doesn't show the account. The account kind of is in the back, right? When we go, for example, we request like interactive app or
Mhm.
something. There should be an account, Slurm account in the back, but in the interface doesn't show us that, right?
Right, so we're in the process of changing up the terminology. So the Slurm account is actually either partition or queue on our Open On Demand. But they are referring to the same thing, like the same line. And you have to input it when you are starting an interactive app, unless you're starting the command line. The other thing that I would mention about that is if you leave that blank, it'll automatically put you into the Gen ActQ. Yeah. So, any questions? Yes.
Are you recording the session?
Yes.
I'm not. Okay. Yes. Yes.
Is there any way to increase the maximum cores per job? Or is that set in the Slurm parameters itself?
Sorry. One more time.
So the question is there any way to increase, so you have the maximum cores per job over there, is there any way to increase that?
So per Slurm administrative account, there's a set amount. No, you cannot increase it above that. So you cannot go into the Gen Ac and say, I want to have 500 now, of course. If your job is running, you cannot increase it either. It's just, yeah, but no. There's a limit on each administrative Slurm account. I know that the term account is confusing, but administrative Slurm account, there's also a limit on that. So no, you cannot increase that.
Okay,
Of course, you can always ask a professor to buy more cores.
Yeah. So yeah. So these are our general.
Does that answer the question? Okay.
So these are our general access Slurm accounts, and these are all of the parameters for that. And we'll go into exactly what like kind of decision tree that you would use to select the best Slurm account for your job. So is it a quick test? Is it going to take less than 10 minutes? You can use quick test. If it takes less than 4 hours and you'd like to run our like newer nodes, you can use backfill or backfill 2. If you require OpenMP or MPI, you can use general access. And then if your lab or professors purchase HPC resources, then you can use the dedicated Slurm account to decrease your wait time. Yeah, and then the parameter, of course, in the submit script is going to be your sbatch-a. With regards to that question that was asked before, we don't have it on our default job script that I was saying before, but you can have flags specific to the memory. If you set the number of cores, it will automatically default to 2 gigabytes per core if you're using general access or if you're using quick test. And the Condor one as well, and then it's a default of 4 gigabytes for backfill or backfill 2. You can specify mem per core using --mem per CPU, and then --mem will do the total memory across. So if you don't want to have to do the math and if you just specify cores, it'll automatically calculate how much you get for memory by multiplying it by 2 or by 4, depending on what Slurm account you're in. Yes?
So, is there any way not to memorize this and when you set the email notification, the notification has this information about how much memory is allocated?
It won't do it for, will it tell you the memory for?
When your job finishes, it will tell you, it will give you an estimate how much memory you used. Before that, we cannot predict that.
I'm asking because sometimes you run an algorithm
Yeah.
and then you want to report it and you say that this algorithm is taking this much time, this much resources, because it's going to be compared to other algorithms.
Mm-hmm.
So if it's part of the program and the program can detect that, then it'll report it in there. But we don't have anything on our systems, I feel, that adds it as part of an email notification.
I'm not sure we have it in production yet, but we
Yeah.
have some tools that show you how much memory a job used, or how much CPU time it will show you the stuff. But to predict in the beginning, it's not. We don't really know how much memory it's using during the run. It's very hard to see as a user. But we looking at how to get it reported after the job finishes. Yes.
Does it also show the specs of the CPUs it used? Like the
No,
CPU
it does not.
application?
No. But you can always ask us. Just make sure that you give the job number, the job ID, because we can usually figure that out what nodes it runs.
The job
But
ID.
don't ask how much memory did my user, what CPUs did my job run. Just please give us a job number.
Yeah.
It will save us a lot of time.
Yeah. Are there any other questions? Okay. Okay. So, I noted on the job script that after you do all of the SBatch lines, there's a module load section, and that's for making sure that the software and the modules that you need for your program are loaded onto the core that you're using. There's a lot of software that's already on our systems that we've installed either for users, so they're actively being used, or we've installed them in the past. If you don't see your program or software on this list at all, you can always ask us and we can install it for you, since we definitely want you to make sure that you have all of the resources that you need to do your research on the HPC. And then, of course, if you are able to, you can also download the source code and compile it in your home directory instead. And below are some of the compilers and programs that we already have. And yeah, and so that's a separate part of it that you may or may not be familiar with if you haven't used the HPC at all. So, modules look like this, and the way that we have modules so that we are loading and unloading them as needed is because we have multiple different versions. We know that sometimes when you're getting software to use or programs to use, sometimes they require different versions of compilers that you may or may not have on your own personal computer. So we want to make sure that we have as much of those available as physically possible. You can see all the ones that are available by doing module avail. And then if you want to load in OpenMPI that is compiled with GNU, you can do module load GNU OpenMPI. Or if you have specific versions of either GNU or OpenMPI that you need for your research, you can list them as you load them. Module avail will give you all of the different versions per package that we have. Okay, so before I move into how to submit a non-interactive job, are there any questions? Yes?
So if I run module load GNU OpenMPI, does that load the latest version of these modules?
Yes.
No.
Okay.
Almost.
Okay.
It will load the default versions. Yes. So there's OpenMPI 4, but maybe if there's OpenMPI 5 installed, it may not be still in a testing phase. So then the default version is not always the latest. Just like the GNU compiler, there's GNU 8 as a default on CentOS, but we provide 11, but it's not the default. So Yeah, sorry.
No.
And then there's one more thing I want to say about modules. It's a hierarchical system. So there's packages for GNU that are not available, that you don't see unless you load a GNU module. So if you, for example, do module avail, you won't see OpenMPI. But if you do module load GNU, then you suddenly see, if you do module avail, it will suddenly show all these MPI packages. It's because that will allow us to have different packages for Intel, GNU, and whatever compiler, version of compiler. So sometimes, like I said, most of these jobs are batch models. Sometimes you want to run a non-interactive. Oh, before I say, are there still any questions? Okay, so sometimes you want to run an interactive job. For example, you want to run a debugger, you want to debug a program, which we have VTune or the Total View. Sometimes you want to just run a Python Jupyter notebook. Sometimes you want to run a parallel R program, not RStudio, but just R. Sometimes you want to run something interactively. That's also possible. Like I said, you can do it through Open On Demand, but you could also use it directly from the command line. So the Slurm job scheduler. Okay.
Yeah. So this is just to reiterate what we talked about before.
Yeah, I used my train of thought was about interactive.
Yeah.
So sometimes I'm a little confused here because I did this presentation in the fall and the spring, and it was so confusing that we're doing it together now, and now it's much cleaner. But so to iterate what we've done with job schedulings. So Slurm is a job scheduler. A job scheduler is needed to make sure that everyone gets their fair share on our cluster. It's if you request some resources, it tries to find the parts that are available and then runs it. There's kind of a fair share algorithm running in the background to make sure that that people will not monopolize the system. You don't want someone to submit 10,000 jobs and then another student cannot run anything. So there is some fair share that student suddenly jumps the line because then they can run. So it's, job scripts are very straight. It's a declarative command language. So there's two sections. There's your preamble where you give direction to Slurm, what is needed, where is needed, how long you need it, or maybe when you need it, because the job doesn't need to be run immediately. And then there's the body of the script. The body is basically as if you type what needs to be done. It directs the computer what to run. So we have, to help people, we have a submit script generator. Submit script generator, if you're new to writing job scripts, it will help you write a template script for you. It's I thought we have are we going to do this interactive?
Okay.
So let's see if I can do this interactive. So demos never work, but where is it? Okay, I had to click it twice. So this is the submit script generator. It's you see on the left it gives you kind of parameters, and on the right it gives you the output. So let's call my name, my thing is ctemp, because it's running ctemp. Now it's running, and the program is called ctemp mixed. I'll leave most of these flags. You can see on the right. You see the options change, but I want all. I happen to be part of a group, which is the HAL lab, and this program runs on 20 CPUs, and it runs for 5 days and 10 minutes. So as you can see on the right, it did the job name, it did the middle type, and it did here. Now, I still need to do a few more things, because I don't need CPUs. I don't want this program uses Anaconda, and it uses Stata and it uses Intel OpenMPI. It automatically inserts the module load commands for me. Now, these options don't make any sense to try to do them at home, but this is just an example. It also doesn't really do any type checking. So if I, for example, now also select the GNU module, it will just accept it, but it will not run. So what do I do here? I can just select this, and I use my favorite editor on the HPC and copy this to a script, which I can then run with sbatch. So if you're new to writing scripts or just want to have quick and easy, you can use the script generator. Let's go back to... Oh. So now how do you submit a job from the command line? You log in with SSH, you create your script either with the job submit generator or with your favorite editor just from scratch. So here's a little animated GIF. You log in with SSH to one of our login nodes. If you get an account, you get an email with getting started, you'll see exactly how to log in. So your SSH to login nodes, your CD to your right directory, which in this case is seminar/parallel. And then I just type sbatch script. This should be able to stop and start this. So in this example, one more time, I log in, I have my login node for the login node. I CD to the right directory, the right folder. If you don't know what CD is, I advise you to look at the Linux presentation. And then I type the sbatch command trap.sh. It says submitted batch job number, and I do sq just to see what is my job, and it doesn't pass. But in the interactive part, we'll show you exactly what's happening. This is just a quick idea. You log in, you CD to the right directory, you do sbatch, and your job starts. So this is kind of, in brief, all the commands that I did. I did SSH, my FSU ID at HPC login for most people, unless you have a guest account. SSH to your login node with your RCC, your credentials. You type the sbatch command, and then you can run the command sq-me. SQ gives a long list of all the jobs that are running, but if you only want to see your jobs, you can do sq-me, and it will only show my jobs. So a few more things. If you're off campus, which I didn't show in the animated GIF, you have to use a VPN. We're not accessible to any machines outside of the campus network, which includes the library, includes the wireless, the campus wireless, not the guest network. But for everything off campus, from your home, from the Starbucks on Magnolia Drive, you have to use the VPN. It's just safety. We receive so many attacks from outside that we kind of have to shield our machines. So if you're outside, you have to use the VPN. Now, FSU uses a Cisco appliance, and you have to use the Cisco AnyConnect. Not going to go into details here. If you look on our website, on the documentations website, you'll see a whole explanation of how to download it, how to run it. But you start the AnyConnect, and then you can use SSH as if you're on campus. So the next step is just you create, you edit, you upload, whatever you create with your favorite editor, you create your job script, which we'll show an example later on. And then you use the srun or sbatch command to submit it. Sbatch is for batch jobs, like the name said, Slurm batch, it's for batch jobs. It will basically, it says requesting access, job started, job number. It will give you a command line prompt. Srun is just tries to allocate something, and then we'll just wait for your to type commands. And if you want to, with sbatch, you can use sq to check, like I said before. Now on your right here, there's a small little example. So it's a bash script, so it has to start with bash. And then there's this 5 lines that tells Slurm, and this should be capital J, I've got one. So there's a minor error in this thing. So sbatch test, so the job is called test. It goes to the Slurm administrative account, GenAC, which is our general access partition. It requests 4 cores with -n for for 15 minutes, and in any event, every event, it will send you an email. Now then the real body is the last 2 lines, which is what happens on the node once the job starts. So the beginning is how, where, and how to run your job. The last part is what to do once your job starts. It will load this Intel module, and it will load an MVA pitch 2 model. MVA pitch 2 is one of these many MPI implementation, and then it run srun trap. Why srun trap? Why not just trap? This script runs on warm core, and srun will make sure that the trap program will start on all the 4 different nodes. MPI, there's a lot of magic in the background. It will initialize communication. That's the M. But srun needs to be run so it can run on all of the resources that you ask. I'm getting a little sore. Yes, go ahead.
So when you create your script, where do you save it before running it? Or how do you save it?
So when you create your script, where do you save it when you run it? That's up to you. So it's Linux. So you have, when you get an account with us, you have a home directory. Home directory, you can store 150 gigabytes of data. So if you just started and you don't have that much data, you can do everything in your home directory.
So I asked the wrong question. I meant to say that when you go through RCC management interface and
Yeah.
you choose your module and it creates this, should you copy and paste it in the file that you create, or
Yes.
there is a button that you click and it automatically creates the file?
No, we're not that far yet. No, that is on the to-do list. But the thing is, you can also combine it with Open On Demand, so you can kind of open an editor in Open On Demand and copy it there. We didn't think about showing it here because then you get into this Open On Demand, but we may show it at an Open On Demand presentation. For now, we just say copy it in your browser, open SSH, and then type nano or VI or Emacs, and then paste it and save it.
Does it matter what you name the file and what extension you put on this script file?
No, it doesn't matter, but it's for your own use of ease. If you just use the extension for bash.sh, so you can kind of keep track of what it is. Just like you call your Fortran program.f or .f90, your C program.c, it's just easier for you if you can see program.sh, oh, that it may be the submit script.
And one more thing.
Yeah.
I forgot, you write, for running this batch, what command do you write?
Sbatch and then the command.
Sbatch.
Yes. Yeah, slurm batch, sbatch. So the question was, what is the command you use to run a job? And it is predictive AI here. So you use the command sbatch and then the name of the script. And here we already did the sh. Just because you don't have to, it just makes it easy to remember. So we'll show a program that's called trap, which is just integration. And then there's usually a bash script that's called trap.sh, which is a job submission script. Now in the Intro to Linux workshop, you'll probably see things that if you have a script that needs to be, the execution bit needs to be set. The nice thing is you don't have to install. So sbatch script, it will take your input data and it will schedule the job. And it will do, what does it mean when it runs job in the background? You will get job submitted, not job ID, and immediately you'll get your prompt back. What happens is that the controller somewhere over here will get a message like, hey, this person wants to run a job, and we'll try to find the resources. If they're not available, it will try again in a minute, etc. until your job starts. But you don't have to wait for it. So if you submit 10 jobs, they might not run all at the same time. Then you may have to wait, but you can just go home and in the morning the jobs have all run, hopefully. That's what we mean with it runs in the background. That's what we mean with it's a batch position. Now you can also, I think we moved some things around. So, like I said, the submit script generator, we showed it. It's to kind of have a template just to generate your job by clicking options. And it's just very easy if you want to kind of easy check. Like I said, there's limited checking, syntax checking. I can just click an Intel module and a GNU module. If I would do that on the machine itself, it would immediately give me an error, like, hey, there's a conflict. Or it would unload it, but it's just to make it easy, just if you don't remember all the options, if you don't remember all the names of the modules, it's just very easy to generate the script. And then you can copy paste that into an editor on the system. So I already showed this, but this is kind of to go through the job script generator again. So you have a title, you have the program that you want to call, and then there's several options, how many cores, how many nodes. This is a slightly older picture. The layout is slightly newer now, but the options are all the same. And on your right, you have the text that you can select and copy to our system, where you can store it in your favorite editor, favorite extension name. So now I want to start a job with batch. What happens is, like I said, it says submitted batch job and then a large number. If you ever get an error, remember that number. That number is what you have to send to us. If you do sq-me, you will see that number. And sometimes it says running. Hopefully it will immediately set running. Sometimes it says PD, which basically means you have to wait until there's enough resources available. By default, the output of your job will go to a file called slurm jobid.out. So if you run a program, if you run trap, the output of it is like the integral of 0 to 1 and blah, blah, blah is 1.7. That output will go to your slurm ID out file. The nice thing that it puts that ID number in the file is if you run 10 jobs, it will not overwrite the same output file. It will just generate 10 different files with output. You can overwrite this, you can give it your own name. If you do the manual of the batch command, you'll find how to kind of give it your own name. But just make sure that that the job ID is in that output file name. If you ever run into issues, submit that slurm jobid.out file in your support ticket. It will make our life a lot easier. If you call the city and say my power is out, and I say who are you? Or if you say my power is out in 150 direct room 5, then they know where to go. So now we're actually going to try it out. Go ahead.
So for those in person, we gave you workshop accounts with login information. So if you're already logged into either your laptop or the computer in front of you, you can go to the ood.rcc.fsu.edu and use the login information on the card for your workshop accounts. And we'll have Jose as a moderator coming over to help if you have issues with that to log on. And then once you're logged on, and this is all included in the login card as well, there's a tab in there that says clusters. It'll have a drop down that has FSU-RCC HPC shell access. Once you click on that, you'll get essentially a terminal that's already set up with that's already set up on the HPC, and these are the commands that you'll type into that black box. And while you guys are typing in all of these, I'll explain what each of the lines of code does. The first one pulls a C program that Paul wrote
20 years ago.
And it essentially copies it into your home directory as trap.c. And if you do cat trap.c, you'll actually see all of the contents of that file populate on your screen. It'll be very long. And that's just to show that trap.c is not an empty file. And then, as we mentioned before, when you want to load or have available software and packages or compilers, you'll have to use module load on our systems. So to make sure that you have MVA pitch 2 loaded on here, you type in module load Intel MVA pitch 2, and that's just our Intel flavor of MVA pitch 2. The code here is a little bit of C program. Yeah.
So after they log in to the terminal, they go command by command,
Mhm.
they write it in?
Yeah.
Yeah, I just asked a question.
Okay. No worries. Apologies for those on virtual, as they may or may not have access to this, but you can always let us know if you want an account later on, and you can follow these steps if you watch the recording again. So this fourth line here is essentially a little bit of C code, which makes the trap.c file into a executable called trap. And what you can do for the fifth line is if you do /trap, you can run that code on the screen and it should give you some output. And that's what our expected output is going to be as we run the S-batch version of this. Lastly, our last line here copies over a trap.sh file, so the submit script that we've made for this program that will essentially run the trap executable on the to run the trap executable on the HPC. So I'll just leave this up, and then I guess I can also field any questions that we have online while we wait. All right, everybody good? Okay, making their way down top. So we're good? We're still going?
I think you have to first tell the limit that it is Python.
Can you go back to the instructions?
Oh, yeah.
There you go.
This one? Yes, because you have to tell limit so that it isn't Python. You good? It's not entirely this, but. How's it going? So now you run it, and now you have to show. So you run it, the six line /trap. What you did is you run it on the one Windows. So that's why it's only one CPU, but now you run it as a job. So did you copy this or you copy the file? And did you do an S-batch on this one line?
Not yet. It's in a couple slides.
Okay.
Yeah.
So now you can deliver a job file to trap at that stage. the last branch that command.
You might show me how.
Page trap.sh.
Right. Ready to move forward? Yes. Okay.
Where's the
Yeah.
oh, never mind. Never mind. So you log in as your own username, and you don't have access to the workshop account. So can you add it to track.sh file? So so the things you log in with your own name will have this one.
Okay.
So what you can do is vi track.sh. You know VI?
Do my- Ready? Okay. So, so this is just an iteration of what the trap.sh file is going to look like on the inside. But instead of general access, it should be to the workshop accounts. Oops. It should be to the workshop accounts since you all have workshop accounts, and that will automatically put you in the line for the workshop accounts. And yeah, so if you wanted to check your trap.sh file, you can just do cat space trap.sh. And then nano trap.sh is in case you wanted to edit this file at all. Okay, so the last thing to do since you have your trap.sh is to run sbatch space trap.sh. And you'll get a submitted batch job and then a number as your following output. And then if you type in sq space -- me afterwards, you should see either that the job is pending or that the job has been completed. If the job has been completed, you actually won't see it on the screen. You'll just see the title headers for that.
Can you go to the previous slide?
Yeah.
I'm going to check the spell of the margin. Oh, okay. Spell.
So if you want to see it, the program for that code, minus code, space, and the name of the file, so track. Space, I don't know if you got it, and that's space. So track is always used to kinetic. You need to math libraries, space, dash L, and minus L.
But then there's just simply all the file.
You have to do dot slash,
Yeah, control. Don't even have all the.
All right.
So now before
run
Was everyone able to run sbatch
So now you have
on
to
their
copy
file?
JavaScript.
Yes. Okay, cool. Were you able to run sbatch
If you scroll up.
on yours? Okay. Cool. Alright, so the difference in output, if you do the /trap on there, you'll see that the number of processors is 1 on the top. And then below, if you do cat slurm - whatever your job ID is, .out, which will also be in your home directory where you've run the code, you'll see that the number of processors is instead 4, hopefully, since we put 4 in as the -n. And it will give you the exact same number estimate for the trapezoidal process algorithm.
How
Yeah.
can they get their job ID number?
So when you do your, when you submitted your sbatch, it will say submitted batch job and then the big long number at the end, and that's your job ID. So if you do ls in the terminal, it should populate and you'll see your trap.c, trap, your trap.sh file, and then also the slurm, whatever number is, .out. Okay, so everybody good with that?
So the number is the job ID?
Yes, the submitted batch job is the job ID. Mm-hmm. All right. And I think that's it for me.
Oh, am I
And
again?
now it's your turn.
I thought we already did interactive.
Nope.
So now we really go into interactive jobs. So we did just a hands-on for batch jobs, which was pretty straight. So how can you submit interactive jobs? There's like I said, there's two ways. There's the open on demand. If you run which is like a virtual desktop, you can run MATLAB, and it will start MATLAB in your browser, and you can do whatever you want, turning of symbols, typing volume, etc. Or you can do it through the command line. Now, the sbatch command is used for non-interactive batch jobs, but I told about the srun and salloc commands. You use srun with the command flag --pty. --pty basically says allocate cores on some machine and connect back to the login node so you can type commands. It says start a physical terminal. Pty is like Pty terminal. So do we do hands-on with that too? No. So if you want to just test it, you can just run srun --pty, and then host name will not be that interactive, or just R, and it will kind of start an R session. So open on demand, you go to our website, ood.rcc.fsu.edu. You log in with your FSU credentials or your RCC credentials, and then there's a lot of options. There's a lot of clutter on the page. Sorry. There's a lot of useful information on the page. And then on the top you see interactive applications. You type interactive applications. And do we have a screenshot? So we were not going to discuss it, but open on demand looks like this. There's all latest information, some examples, but if you go to my interactive sessions, I have nothing. If you go to interactive apps, you get a whole list of things you can do. And you click on, for example, MATLAB, and it will show you all the same options that you can use in your thing. So there was a question before about partition account to queue. The correct terminology is slurm account for an administrative account, but a lot of people still use terms like partition and queue. We're going to go through all the documentation, make sure that we all use accounts, slurm accounts. But yeah, it's a lot of work, and we're a very small team. So open on demand works through a web browser. It's like a virtual desktop environment, and it's so.
And that's what it looks like.
Well, we decided to do a slide in there anyway. So this is an example of you go to the website, you click applications. In this case, it's RStudio. So there is this partition which should be account. The number of hours. This almost looks a little bit like that JavaScript generator. And in the background, it is similar. So it's some of these RStudio. We can have multiple versions of R. RStudio is basically a graphical user interface for R. We have multiple versions of R. You can pick that in the modules here. Sometimes you may need other models, additional models, although we don't really offer that. So you can load the GNU if there's anything that R depends on GNU. And then you just launch. And if you launch it, it will give you a screen that says your job is starting soon. And then at one point it will say your job started. Click here, and if you click here, it will open a new tab. And you have RStudio. We're not going to go into that much detail. We have a separate workshop on it at some point. If you're interested in it, there's not a specific HPC workshop on open on demand. There's one for digital humanities. But if you're interested in open on demand, I would definitely come here. TSL 208, if you walk around campus and you come back to this room, you'll be here. It will be given here in Direct Science Library, the second floor. It will also be online, but I would really advise everyone to be here just because it's a hands-on experience, and online you will not get a lot of support, but here you have a lot of people who walk around and help you. So even if you know the digital humanities, because there's almost no one is that, but sorry, then you're still encouraged to attend. This is about open on demand for a specific domain, but it's still very useful if you want to get used to open on demand. It's on October 24th, next month. Be here or be squared. So, like I said, there's this. You can run interactive jobs from the command line. There's two ways to run, as alloc, and as run. As run is usually what most people use. As run is the slight confusing part is that you can also use as run in your bash script, but this is where the slurring people made a little error. They should have named this different. This is as run is to, on the login node, is to start a job on a cluster and then get the input and output back to you. So like I said, it's interactive submission. It runs in the foreground, and it connects back to it. It waits for your input to type. The subtle difference between as run and as alloc: as run will land you on the compute node. As alloc will keep you on the log. As run will run on the compute node. As alloc runs on the login node. But as alloc allows you to submit stuff to that partition, the resource that you ask. I'm not entirely sure how to properly do that, but you have to really play with it a little bit. Most people will just use srun-p2i. It allows you it says interactive use of specialized hardware, and like if you want to have something run on a GPU, of course this is also true for AshBash, but if you want to run an interactive job. If you have a 16-core job, a 16-core program that crashes, and you want to run a debugger, we have a total view. For total view, you have to do the same thing. It will also run interactively on our compute nodes. So this is an example. So, like I said, as run, you give the -A backfill too. So this should be -A, but you can also use -P. You give it a time you want to run for an hour on 16 cores. You want to have 2 GPUs. And the most important part is --P2i. If you run this without P2i, it will give you a little error, but you cannot type. It will start, but it will not type anything, because it will start bash, but there will nothing be to input. Now bash is smart enough, it will see that there's no input, so it will crash and immediately stop. So, yeah. So we have this long line, and then the end result is that you get this prompt, which basically means this job is started on this HPC i36-1. So first let's stop. Does anyone have questions about this? Are there any questions online? Interactive, you really have to do it yourself. A lot of this is you have to do it. You can read about it, you can read 500 pages of manuals, but you have to do it. So what we've covered so far, we started with our definitions. What is HPC? What are typical HPC jobs? What is HPC used for? Is it a program that needs a lot of memory? Is it a program that needs a lot of time? Is it a program that needs a lot of cores? Then an HPC cluster will be perfect for it. We covered how you can submit those jobs, how you submit them with the job script and with all this as-batch and as-run commands. We show you how to submit non-interactive jobs with as-run, and as-batch and as-run to submit non-interactive and interactive jobs. That, in essence, is how you can start a job. And thank you. No. So let's move forward. I'm not sure how much time. How are we on time?
Yeah, so we can probably finish moving forward. And then
Yeah. So Here we are into the kind of some of the kind of the nicer details. So imagine you're sitting, you don't have an account. You want to run on our systems, and there may be some people online that don't have an account yet. So there's a few requirements for an RCC account. An RCC account is free. Everyone can get an account. Everyone can get limited access to some of the resources. The only requirement is either you have a faculty appointment or you have a faculty sponsor. It's an administrative kind of requirement. If students come and students go, but we want to make sure there is some tracking and accountability. So if you're a student, your professor has to approve your account. If you're a guest user, if you're working together, if you have collaborators from outside, they can get accounts on our system too. We're very easy. If you're working together with a research group, if you're outside of FSU, you can get an account too, but you have to work with someone, you need a faculty sponsor too. Now if you're a non-FSU, there are some other requirements, like you need a guest FSU ID. But if you're in that situation, on our website we show how to do that. If you try to log in, then it's so. So how do you get an account? There's the link RCC. You can go to our website and there's somewhere manage your account. You can click that, or you can go directly to rcc.fsu.edu/manage. Recently we revamped some of our websites. It was kind of moved over to another service provider, but we still manage that accounting website. So you go to our website, rcc.fsu.edu, click on manage accounts, and you'll get to this screen here. You have to log in with your FSU credentials. Not your RCC credentials if you already have them, but your FSU credentials. That makes sure that we know who you are. Then we can see if you need an account or not. In this screen, if you don't have an account yet, it will ask you if you want to create a system, what's called a system account, which is on our system. There's a lot of options in there, and one of them is, if you're a student, pick your professor. I don't sponsor accounts in general. Don't pick me unless you have a reason. Send me an email if you don't have a professor or need someone else to sponsor you. But in general, pick a professor that you work with. Now you fill out all the details. You put in the password. You request an account. Imagine it gets approved. Now you want to run on our systems, and you know that your professor has bought resources. If you're new to it, you can use the general free account, but if you want to have special access, if you are part of Earth and Atmosphere, if you're part of the EOES department, they have a lot of resources. If you're engineering students, they have a lot of resources. If you want to be part of a special project. So how you do, you log into our managed website, and there's a few options on the left side. There's account, which is like if you want to change your password, if you want to change whatever shell you use, if you want to enroll to whatever mailing list we have. We currently only have 2, but you can enroll there or unenroll to our mailing lists. Then there's the groups. The groups is how we manage access to our systems. So if you want to, I'm not sure if you want to enroll to a certain account, Slurm administrative account, you go through groups. Or actually you go to partitions. So you click partitions, and in this case, Dr. Uner Christian is an engineering professor, and I'm just a new student, so I go to the whole list of accounts, and I look for him, and I see this UniQ. I said, oh, that's my professor. He told me to enroll in his account, so I click more information. I see this, the details, default job, how many courses he bought. He has 900 courses, which is a good amount. Then underneath there's groups, and it says Uni Group. I click on Uni Group, and since I'm not in there yet, it says request enrollment. Now, Professor Uni likes to know who is enrolling into his resources, so make sure that you type in a good reason, because he may not know you. Especially with large departments, they may not know all their students, and I've seen in the past with physics that the professor said, I have no idea who this is, and he just rejected. So I say I attend your class, I'd like to make sure of your resources. I click submit request, and then Professor Uni will get an email and say approve or not, and you will get an email once he approves you to his resources, and then you can use that information in your sbatch commands. You can do sbatch, and you can see it here, UniQ. I have access to his account. So to reiterate, Slurm has a lot of commands. There's a lot of different things, and we've only talked about sbatch and srun, and we carefully mentioned SQ. So we go through a few of these commands that you probably will use if you start using our system. So there's sbatch to submit a batch script, a non-interactive script. There's srun or salloc to submit an interactive program, and we should update this. But then there is, if you want to see all the jobs that are running, if you want to see your own jobs, if you want to see all the jobs that are in your professor's partition, you can use SQ. Now we showed SQ -- me. There's also SQ-A Slurm account name. So if you do SQ-A or -P uni_Q, you'll see all the jobs in the professor's partition. There's a few specific ones. If you know your job ID and you want to look at what's happening with my job, if you have 100 jobs running, you don't want to do SQ-me because it'll just give a long list. What you can do is use the command scontrol. Scontrol show job, and then the job ID shows a large screen with all kinds of information, like when did the job start, what is the expected stop time, how many resources am I using. Now, at one point you may realize, oh, I made an error. There's an error in my program, it produces only zeros. Do I let this run for 2 weeks, or do I just cancel it so I can run a new job? You can use scancel from cancel, Slurm cancel, with that job ID. If you want to see what's happening with the notes that your professor bought, you can use sinfo and that account information. Now sinfo used to show a lot of useful information, but now it will just show a giant list of notes, so it's not as useful anymore. But you can still see a little bit if you're interested in the names of our compute nodes. So we're getting into the troubleshooting. The troubleshooting Slurm is very complex. If you look under the hood, there's like thousands of jobs waiting in the queue to run. And it's a very complex software to schedule all those jobs. And if you make a tiny little error, then your job might not run. If you ask, for example, for 2 terabytes of memory on one node, Slurm will not stop you from asking that. But of course, we don't have those resources, so it will never run. And there's so many things. If your professor bought 1,000 cores, but one of the other students is already using 950, and you want to run a job that's 51 cores, your job will not start. Now, if you do SQ-me, you will only show your job waiting. But if you do SQ-A UniQ or whatever professor, it will show you that, oh, there's suddenly a lot of jobs in there. That's the reason. You can do show scontrol to show that job, and it may give a reason, like, for example, if you ask more CPUs than you're allowed to, if you submit more jobs than you're allowed to, whatever. It's usually good to just quickly look at this scontrol, this SQ account, and if you really don't understand why your job is not running, you can always ask us, but make sure to include at least the job ID and preferably the location of your job script. You don't have to include screenshots, just give my script submit.sh in my home directory is not running. This is the job ID, then we can have a look at it. Now, how do you get access to us? How do you request help? There's an email address, it's support@rcc.fsu.edu. And it will show in one of the next slides. So to iterate, support@rcc.fsu.edu, and try to include as much information as possible. What you try to do to solve it. If your program gives a segmentation fault, it's usually your program, but there may be something else wrong. So include the path to your job script, your output files. If your professor has a giant storage allocation, we cannot find all your files. So give a location. And give the error you receive. Not, it doesn't run. It's just try to be specific. I mean, sometimes it's confusing, but try to be specific. And especially if you use if you use MPI, MPI can be very confusing. You get, there's one error on the top and 50 other errors below because they're all related. And if possible, include your job ID. So, like I said, we are a small team. We're in direct. We actually are downstairs here. We have a systems team. We have an application team with specialists. And they will be happy to help you. So if you ever need one-on-one, personal contacts, just contact us through the support at RCC web email. We do work hybrid, so we don't really have walk-in hours. You can come downstairs and see if someone's there. The easiest is just to send an email and say, hey, I would like some help. Can you schedule a time with me? That can be in person. It can be online. We're very flexible. But we're just only a small team, so it's not that we can immediately start and help you, say, the whole day with your program. We don't do your homework. And otherwise, we have lots of documentation on our website, docs.rcc.fg. Is it doc or docs? Docs. docs.rcc.fg. It's a lot of documentation online. And thank you for attending. And we have several other workshops planned for this semester. We have an introduction to parallel programming in MATLAB, which is very exciting, because MATLAB is not just a desktop application. It can do a lot of stuff, including parallel things. We have the Photogeometry Institute event, which is in Strozer. And then we have the Open on Demand for Digital Humanities, which is here. So I think these are all very exciting things to do. And especially the photogrammetry, because it's on the edge of research computing and interactive. So if you're interested in like cool buildings on screen, I know it's much more than that, but it's. Thank you for attending.